we are going to take a quick look at how we can use computer vision techniques to do object detection in thermal images and how this could be applied to surveillance systems. Aerial surveillance using drones is becoming increasingly popular in modern-day security applications, but adverse weather conditions, as well as terrain foliage, can make the process of detecting objects very difficult. Thermal images step up as the solution to most of these problems, and you are about to see a nice example of this when we manage to detect elephants in a natural reserve. The computational approach follows the following points. First, we need to read in the data to pre-process it and train our classifier. The classifier we're going to use is a support vector machine. We're going to find hog pictures for our dataset, and we're also using a sliding window and a Gaussian pyramid to detect the objects of interest. And of course, we are going to print very nice examples to see how this works. This process can be seen in the following flowchart. We start by preparing our thermal images, making them all the same size, and then we proceed to extract their hog features. After this pre-processing is done, we train our support vector machine and obtain a nice model that will do the detection in our test set. But what are all these fancy terms we use? The hog descriptor, hog being short for histogram of oriented gradients, is based on the fact that the presence of objects, as well as their shapes, can be described using gradients. Gradients quantify the change of intensity of one pixel with respect to its neighbors, so they're very useful to detect edges. This is perfect for our application, since abrupt changes in intensity are more noticeable in thermal images. An SVM classifier is a very popular supervised machine learning technique based on the idea of finding a hyperplane that best divides a dataset into two classes. Using this, we spotted a few elephants here and there, as well as several herds. We ran our tests on a dataset consisting of wild elephants in forest reserves, and the results are amazing. Here you can see some cool results. And of course, as with any classifier, there are some subtleties here. Sometimes our boxes will not enclose all of our subjects, and we think that this is due to the fact that our training dataset did not have enough examples of these types of pictures. In any case, results look pretty good, but there are still some more cool things we could certainly do here. We can improve our dataset so we can have a better trained model. We can go to the next level and create a multi-class object detection tool, where we can include animals, humans, and vehicles. And even better, we could do this in real time to detect objects in videos. Thank you very much for listening. Have a good one.